Let's do a truth table for this compound statement here. It's problem 18 in our textbook on page 111. And it's not too bad. Now we know when we start with PQ only, two statements P and Q, we do true, 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 and so on and so forth. But here we're going to do this. For the first statement, we're going to make it half trues and half falses. It's kind of what we did when there were two statements, but there were two trues and two falses. And then here we're going to treat it like we used to treat the first statement. So it's going to alternate in groups of two. And this third one's going to alternate true, false, true, false, true, false, true, false. This is just a good start when there's three statements. Let's make a deal. Let's put P, Q, and R in that order always. The book once in a while, like on problem 17, doesn't seem to do that, but it's going to work out best for you if you put P, Q, R in this order always when there's three statements on a truth table problem. And always start out with P, half trues, half falses, and then alternate in groups of two in the second column and alternate in groups of one in the third column. This gives you all the possibilities from all true to all false, and it gives everybody the same start every time. Again, if a problem like 18 is on the exam, I will start it out for you this way. This stuff right here will be on the exam because I don't want people doing it 300 different ways. It's very confusing to say the least. Now, this is our goal. That's what we're trying to aim for. So what kind of pieces do we need? Well, we've got an R and we've got a Q, but we don't have a not P. We don't have the negation of P. So it would seem like we need a negation of P column. P is 4 trues, 4 falses. So the negation would be 4 falses and 4 trues. Negations don't usually cause too many people problems. Now we need an R and a Q. So let's do R and Q. Now this is Q and this is R, and we know that with an AND statement, the only way it's going to be true is if they're both true. Anything else is false. So I usually go through and pick out the ones that are both true. And it looks like everything else is going to be false. Because the way an compound AND statement, a conjunction is true, is if both pieces are true. And now we need another AND statement, but this time it's our R and Q, and we're going to do a conjunction of that and not P. So what are our two columns? Our not P is here, and our R and Q is here. So we're going to do an AND on those, and again, the only way this AND statement can be true is if there's two trues. So I like to go down and look for the two trues. It's got to be down here somewhere where these first ones are true. That's the only one that's true. The rest have at least one false in them. Some of them have two falses in them, so they're all false. And I believe that is probably the easiest way to do a truth table. The book has some other suggestions, but I kind of like this. I kind of like piecing it together. And you can look at their examples in the book and this example and do a pretty good job. This example is problem 30 from page 112 in our textbook. And we're deciding on the truthhood of this statement right here, given, in part A, given these three facts. So it's like a piece of a truth table. We don't actually need the truth table to do this, so let's just give it a try. So P is true here, but this is the negation of P. That means P is false. The negation of P is false because P is true. And we have an and then we have the negation of Q. Q is false, so the negation of Q would be true. And then we have the negation of R. R is true, so the negation of R is false. And so now, what about if we have a compound OR statement with true or false? Well, do you remember that ORs are almost always true? If any part of it's true, it's true. So we have a false, and this boils down to a true. But false and true, the only way a conjunction is true is if both of them are true. So when you have an AND statement with only, one part of it being true, it's false. And so this particular problem, part A, we have a false statement. Now let's go to part B. These are the assumed facts of the matter. I'm just going to kind of use this over again without rewriting it. And so we have not P, the negation of P. P is false, the negation of P is true. And the negation of Q, Q is true, so the negation of Q is false. Or the negation of R, R is true, so the negation of R is false. So we have true and we have false or false. And that's the way an OR statement can be false, is if both parts are false. And so again, we have true and false, just like we had false and true in the last case. And so part B is false. Part A is false. Part B is false also. In problem 38, from page 112 in our textbook, we're determining the truth of this compound OR statement. It's a disjunction. It's an OR statement. The symbol for an OR is this V-type shape. And we need to know if this is true or false. Now, we know something about ORs. The basic fact about OR statements is that they're very often true, because only one part needs to be true. So we're going to have an answer of true if either one of these is true, or if both of them are true. The only way we can have an answer of false on this problem is if both of these separate statements are false. That is the basic fact about OR statements. Well, 0 is smaller than -3 is the first example, but if you think about a number line, -3, -2, -1, 0. 0 is not smaller than -3. 0 is to the right of -3. It's bigger, so this is a false statement. And this says 5 is greater than or equal to 10, and that's a false statement. So when you have an OR, compound OR statement connecting two false statements, that is the only way it can be false. So 38 is false. This next example is problem 60 from our textbook. We're translating the following sentence. The house is not owned by an engineer. That's the negation of P. And the car is not run by electric power, so and then the car is not run by electric power, that's the negation of R, and the heat is solar generated, so that's and Q. So now we're supposed to do a truth table for this, so we're going to fill in the beginning part of the truth table the same exact way that we've done before. And as a quick reminder, that way is please always do P first, Q second, R last. Make the first 4 of these true, the next 4 false. First 2 true, and then alternate. It's a little bit dull, but it doesn't take too long to do this. And it gives us all the possibilities, and it has everybody doing it the same way, which has some benefits. Now we need to head here, and it looks like we need a negation of P and a negation of R, so I'm going to do a negation of P followed by a negation of R. The negation of P, instead of 4 trues and 4 falses, it will have them reversed. 4 falses, 4 trues. The negation of R starts off false and then alternates true, false, true, false, true, false, true. Now it looks like maybe it's time for this AND statement. So we have AND, the negation of R and Q. Now sometimes I get a little bit lost, so the negation of R is here, and Q is over here. So it's these two columns that we're looking at. And on an AND statement, the only way it's going to be true is if there's both trues. So we're looking for Q and the negation of R. We're looking in here for a couple of trues. Here on the second row, there's a couple of trues. Here, there's a couple of trues. And there's no two trues anywhere else. So the rest of these are false. But we now need the final step, which is not P, or the negation of P, and then this AND statement that we were working with. So now where are those? Well, the negation of P is right here. It's in this column. And this stuff is in this column we just built. So we're doing an AND on those two things. And again, with an AND, the only way it can be true is if they're both true. So I'm looking for two trues. It can't be in these falses. So I'm really looking down here in these four trues. Here's a true, and that seems to be the only one. So everything else in this statement is false. And so based on the order we did this in, the only case that makes this compound statement true is this case right here, which the book sometimes calls, the sixth case, because it's the sixth row. But it's the case where P is a false statement and Q is a true statement and R is a false statement. So the house is not owned by an engineer, the heat is solar generated, and the car is not run by electric power. So this is the truth table, and the sixth row is the only set of conditions that can make this compound statement true.